Hi guys, welcome back. Guess what? You have more derivatives to memorize. Oh boy, yay! Don't worry too much though. This is something that we won't do all year. You just got to know that when it pops up to look up the formulas, and yes, you'll have to memorize it right before the AP exam and before your next test, but it's not too bad. All right, derivatives of inverse trig functions. Here we go. First, this is what inverse trig looks like. What does it mean? Hopefully remember from calculus from pre-calc, that this is basically asking when does sine equal the square root of 3 over 2? Okay, so it's a unit circle question, okay? Right here at pi over 6, the cosine is square root of 3 over 2, so that's not it. We must want this one, okay? This is when sine is equal to square root of 3 over 2, so that would be pi over 3. And now you may remember that you only use certain quadrants for inverse trig. And it's basically for sine, it's this quadrant and this quadrant, just basically where all the signs would be different. Because here, this would be square root of 3 over 2 and negative 1/2. And here, this would be 1/2 negative square root of 3 over 2. So notice it gives you all of the options for sine. So you have the positive and the negative, the positive and the negative. So we use these two quadrants for sine. For cosine, we use quadrant 1 and 2. And for tangent, we also use 1 and 4. Okay. You also might remember that if you give this answer right here, we don't call that 11 pi over 6. We call it negative pi over 6. Okay, remember this is up pi over 6, this is down pi over 6. This would be negative pi over 6. This is pi over 3, this is negative pi over 3. Okay? And it has to do with keeping it a continuous function. All right, so number 2, when does cosine equal negative square root of 3 over 2? Well, cosine is square root of 3 over 2 here, but negative would be over here. So that's 5 pi over 6. Okay, tangent. When does tangent equal a 1? Well, tangent equals 1 when your cosine and sine are the same, because tangent is sine over cosine. So that would be here and here, where you have the square root of 2 over 2 for both of them. And here, because they're both negative but the same value. So this number divided by itself would give me a 1. So my answer there would be pi over 4. Okay? Over here also, if we weren't doing inverse trig. Okay, so that's just a quick review. That'll come up when you're trying to evaluate or write an equation of a tangent. All right, so our job, though, is to do some calculus, and that's not calculus. That was a quick review of some pre-calc. Okay, before we get started, though, notation. Are these two things the same? No, they aren't. This would be 1 over sine, okay, or cosecant. This means inverse sine. And inverse sine could also be written as arc sine, okay? In fact, I think the AP exam uses this symbol more often, arc sine. So don't let that confuse you. They mean the same thing, okay? Let's get started. All right, we're going to try to derive the formula. This is one of those parts where you could, if you don't care about knowing where it came from, you could fast forward or put me on super speed and just memorize the formula at the end. But I'm going to at least show you where it comes from. If I want to, in the end, right now, this little show that I'm about to put on, I just want to figure out what is the derivative of inverse sine. So I'm going to start by writing an equation, okay? So that I can take the derivative of both sides, okay? Well, I can't take the derivative of both sides right now because we just discussed I don't know what the derivative of this is yet, okay? So I'm going to rewrite it. Since I can't work with this, I'm going to rewrite it an equivalent way. This means the same as this because for inverses, you switch x and y. Now, I'm going to take the derivative of both sides using implicit differentiation. The derivative of sine is going to be cosine y dy dx, and the derivative of x would be 1. Okay, now I can get the dy dx by itself, divide by cosine y, and you get this. You might think you're done, but remember our initial goal. We're trying to find a formula for this, and this guy is in terms of x. This one's in terms of y, and that's not convenient. So now we're going to do some crazy trickery. we're going to find a way. And when you think about who figured this stuff out in the first place, that Leibniz and Newton, those guys, that's who. Okay, we're going to try to find a way to get rid of this cosine y right here. Okay, that's my next goal. So some trickery. Where, what are they going to do? Well, off to the side, we're going to use that one trig identity that you actually know, this one. And my goal, remember, I'm trying to get rid of this cosine y, so I'm going to isolate the cosine y right here. Subtract the sine squared and square root, okay? Subtract and square root, but we want to keep it a function, so we're going to keep just the top half, no big deal. And if you get cosine y by itself, it's the same as this, okay? Oops, let me go back a little because I skipped it. All right, so right now we have cosine y is the same as this. So I'm going to replace the cosine y with what it equals. So that turns it into this, but what the heck? I still have it in terms of y. I thought we were trying to get rid of the y. How am I going to do that? This is the cool part. This is the cool part. Okay, I want you to look all around on this screen that you're looking at right now. We can get rid of this sine y squared. Find a sine y up there somewhere. And how else could I rewrite sine y squared? Well, sine y is the same as x. So now I can replace this sine y with an x. And that is where this formula comes from. The derivative of inverse sine is, oops, I keep hitting the wrong button. The derivative of inverse sine is this formula. Okay, so the derivative of this is this. Now, I'm never going to make you regurgitate that. I just think it's kind of cool. How the heck do these people think of this way back when? Here's what you actually have to memorize. And it looks crazy, like I'm psychotic, but trust me, it's not too bad. I'll show you how to memorize it, okay? So we just found the derivative of inverse sine, but I could use that same process to derive inverse tangent and inverse secant, okay? Now, honestly, this one, the first one's very common. The second one, even more common. And this one, I don't make you memorize, even though you're supposed to. It very rarely shows up on the AP exam. I will make you use it, but I won't make you memorize it. All right, so these guys, all right? Notice they all have 1s and u's squared. So when you're trying to memorize it, you have a 1 and a u squared, a 1 and a u squared for both of them, okay? Sine has a s for square root and subtract. S, square root, subtract. Tangent, the T looks like a plus. Yeah, yep, that's what I'm going with. Now, at the end of both of these is a du, okay? Because that involves the chain rule. So it's times the derivative of whatever was behind it. So there's a du at the back of both of these, but you can also put the du up top. All right, it's easier than it looks. Let's go ahead and apply it, okay? So remember, inverse sine has a square root to subtract. Tangent has a t like a plus. Here we go. Oh, before we go any further, FYI, these are the other inverse trig functions, which they really never, ever, ever ask. But if you see this question, notice that it's really not different, not hard to remember, because all the ones that start with a C, they're just the opposite sign of the other one, okay? All right, here we go. All right, so tangent. Let's see if you can first remember. This could also be written arc tangent. Okay, this could also be written as arc tangent of 2x cubed. Same question, okay? All right, so let's first write down our formula. The derivative of inverse tangent of u is, we have a 1, and a u squared, okay, for all of them. And tangent looks like a plus, but don't forget du. Okay, so u is this. Your u is going to be 2x cubed, the thing behind the inverse tangent. Find du right now, just to play it safe, that's 6x squared. Put it all together. Use this formula. The derivative will be 1 over 1 plus u squared. Well, that thing squared is a 2x cubed times another 2x cubed. So that's a 4x to the 6th times du times 6x squared. And you can stick that on the top. And that's it. That's all you got to do. Okay? So remember, u is this, and then find du, and you're just plugging into that formula. Super easy. Okay, let's try another one. First, we got to remember the formula for inverse sine. Okay, the derivative of inverse sine of u is, we have a 1. We have a 1 and a u squared and a du. I'll go ahead and put it on the top. But sine s has a square root and a subtract. Okay, my u is 1 minus 2x. Du would be the derivative of that, negative 2. Apply my formula. The derivative will be 1 over the square root of 1 minus u squared. That's going to be a 1 minus 2x times another 1 minus 2x. You're going to have to FOIL that. And you get 1 minus 2x and another minus 2x and plus 4x squared. Now all of that would go in parentheses. 1 minus 4x plus 4x squared. Times du, which is a negative 2. Now you just have to clean that up a little bit. Distribute your negative, okay? So I have a negative 2 on the top and a square root of. This is going to be a 1 minus 1 plus 4x and minus 4x squared. So those 1's go away. And we get this. Now, possibly that's the answer, but it's not. So just a little warning. This one has a little tiny trick at the end, okay? So sometimes you're done at this point, sometimes you're not, just like simplifying fractions. All right, it's because, did I leave off a square? Yes, I did, right here. Okay, because the denominator has a common factor of a 4, and because I can square root a 4, I'm going to do another step. I'm not going to factor out the x because I won't be able to take it out of the radical, okay? So from here, in the denominator, I'm going to factor out just the 4. And the only reason I'm doing that is because I can then, since it's multiplication, I can take the square root of 4, which is 2. And now these 2's can be canceled. So your final answer ends up looking like a negative 1 over the square root of x minus x squared. Okay? Hope you're doing okay. I think I keep the problems pretty straightforward for your homework today. So, good luck. It's a pretty short worksheet. Hopefully it goes well. Bye.